The video retake is going to cover just two quick examples on graphing exponential functions. As a reminder, when we're graphing exponential functions, we always want to make a table, at least for now. And when we make our table, we still want to use that -2, -1, 0, 1, and 2. But you can use any numbers that you want. It's nice to have some negatives, though, because exponential functions will always have a floor. And it's helpful to kind of find out what that floor is by using some negative numbers. But when I begin my graphing process, I do like to start with 0. So if I do 2 times 4 to the 0th power, that becomes 2 times 1, because anything raised to the 0th power is equal to 1, which means 0, 2 is our first ordered pair for our exponential function. From here, I can try 1. So 2 times 4 to the 1st power. That's 2 times 4, which is just 8. So this one grows really quickly. And the reason why this is growing quickly is twofold. Number one, we have a number out front that's multiplying, and the base of our exponent is a large number. So we're going to get even higher rates of growth than we were getting in the original video. That's 16. So this is 2 times 16, which is 32, which is off the graph completely. So growing really, really quickly. So let's look at the negatives and see how that changes this a little bit. So 2 times 4 to the -1st. This is equal to 1/4. So I get 2 times 1/4, which is 2/4, or 1/2. Okay? So 1/2 would be right here for our -1. Now 2 times 4 to the -2nd power, that's 16 in the denominator. So that's 2 over 16, which is 1/8. So even smaller, but it looks like our floor is going to be right here at 0. And a way to check is if I'm sitting there going, okay, so I wonder what the floor is. So I'm going to pick -10 as my x value. Okay, I'm going to pick the smallest number that I can off my graph, and I'm going to plug it in here, and I'm going to see what value do I get for x if I plug in -10. So I do 2 times 4 to the -10th. Okay, so 4 to the -10th is something that I don't know in my head, but I do know that it's going to be like this. Okay, so 4 to the 10th power is going to be some huge denominator. Okay, so 2 divided by that, though, is still above 0. And because I know that it's above 0, it tells me that it's going to be tiny, 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 tiny right there, right as close to that line as we can possibly get, which means that all of these numbers are going to be above 0. I'm going to try really hard to draw this well. Ugh, that wasn't great. It's so hard on this board. There we go. That's about as good as we're going to get. So the big key is to find that edge and make sure that you figure out what your minimum value is, or that floor, as I like to call it. So our domain is we can pick any x value. There are no restrictions here. So all real numbers for x. Now our y is going to be any number that's above 0, because we can do anything up this direction. So it's going to be all real numbers above 0, which, once again, if we want to write it in this form, it's numbers between 0 and infinity. Well, you can't actually be infinity, so it means every number that's above 0.